Okay, today's journal entry is on metric measurements. Got page 3 here in your journal. Here's the paper you're going to need to cut apart to put it in there. Okay, before I forget, let's turn to the table of contents, which I totally did forget for our page 2. So, the date 1/13 or maybe 1/14, depending on your class. That was the day you did page 2, significant figures. And that was page 2. Okay. And this is going to be the 14th, page 1, date 1/14, metric measurements on page 3. Okay, page 3. So there's your table of contents. Be sure to stay up to date with your table of contents. Okay, so metric measurements. The paper, cut the border off around the box. Okay, the pictures down here, you're just going to cut them into sections. Cut this into a section, this its own section. Once you have it all cut apart, it's gonna look like this. You'll cut along all the dotted lines. Cut on the dotted lines only. You end up with 3 long strips like that. Okay, and then 2 sets of pictures. Go ahead and trim up the extra paper, extra white paper on there. And go ahead and pause until you finish cutting. Okay? Pause to finish cutting. Alright, so let's get this journal entry done. Okay, put all of this papers to the side for right now. First, we're going to talk a little bit about metric measurements. In life, we measure things. In science, we do a lot of measuring. The problem with the way things were hundreds of years ago is that scientists in one country had their set of measurements and scientists in another country had a different set of measurements. And so some scientists got together in France and they decided to set up the metric system of measurements to make a universal set of measurements for all scientists. So, all scientists use these metric measurements, okay? And also, all countries with just one major exception. Okay, so the metric units are used by all scientists in all countries with one exception. That exception, except the US of A. We have retained our old measurement system, which means we are the only ones really that don't do it, which makes it obviously much more confusing and difficult for you to understand measurements in science. Sometimes these are called the SI units. That's French for System International. Okay, so it's the International System of Units. Or metric. I tend to call it the metric units. Alright, units, when we're talking about units, we're talking about units of measure. How you measure something. Okay? So here in the United States, what are our units? So the US units of measure. How do we measure things here in the United States? Well, measurements we use miles, whereas the rest of the world uses kilometers. We use pounds, while the rest of the world uses kilograms. We do inches and feet and yards, while the rest of the world uses centimeters and meters. Okay? We have ounces, which are actually 2 different types of ounces. There's ounces for mass, or for weight, and then there's ounces for fluids, so fluid ounces. Okay? We also have cups and teaspoons, whereas the rest of the world uses milliliters. Okay, we've got gallon, and quart. Now here's the funny thing. Here's our system, but how many of you know how many cups there are in a gallon? Probably not. Any of you. All right? Temperature. We use Fahrenheit. The rest of the world uses Celsius. Okay? And they kind of go on and on. Things you've never heard of, things like furlong. There's a ton of metric units out there ton of US units you've never used before. All of these, we don't use them in this class. I want you to cross it out. You do not use these units in science. We use the metric units. Some of these you're familiar with, some of them you're not. So we're going to focus on learning the ones that we use the most in physics. Now, of these 3 long strips you picked up, we're going to first talk about the one that says on it kilogram. Okay? So grab that paper. This paper you're going to fold on these 2 solid lines. You're going to fold this edge in like this and the right edge in like this. So the 2 ends are going to meet in the middle. Okay? Working on the one that says kilograms. Now, the highlighter, you need a highlighter for this. I want you to highlight this one part, the base unit kilograms. Okay? So when we're measuring something in kilograms or in grams or milligrams, what are we measuring? What physical property of the object are we measuring? It is the mass. Now some of you may have thought, oh, the weight. I want you to, on this other side right here, write the word weight. Circle it and then cross it out. Mass and weight are not the same thing. They are similar, they are related, but they are not the same thing. And I'll explain that when I teach you about gravity next 9 weeks. Well, much later on. Okay? So mass and weight. Okay? So let's learn about mass. We're talking about mass. Well, base unit. Key concept here, base unit. Base unit are the units that we use most of the time, especially if we're ever doing any calculations. In physics, all we ever use is kilograms. Okay? So, kilograms, for example, if you're going to be measuring something in kilograms, something you might measure in kilograms would be the mass of a person. Okay, so if you go to the doctor and you get on the scale, they're going to tell you your mass in kilograms. Okay? Grams. This is another common unit. Alright? These are common units, but not the base unit. The base unit is kilograms. The common units, grams and milligrams. Okay? Something that's measured in grams is the mass of a serving of food. For example, cereal. If you look on the box of cereal, it'll say right there serving size in grams. Or a candy bar or something like that. It'll tell you the serving size in grams. Alright? So kilograms are larger than grams. Grams are larger than milligrams. Milligrams are actually very, 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 very small. Something that we actually are used to that is actually measured in milligrams is medicine. Okay, so the mass of medicine, let me give you an example. I got here a bottle of vitamin C. Alright, so these tablets of vitamin C, 1,000 milligrams. Okay, so the mass of medicine. Alright, instruments of measure. Alright, so these are the units of measure. Here are the instruments we use to do the measuring. So a hospital scale is what we would use to measure kilograms. Okay? Notice you need to know those abbreviations. kg for kilograms, lowercase g for grams, lowercase mg for milligrams. Okay? The hospital scale, kilograms. All right, a triple beam balance. Now look at your pictures. Okay, find the triple beam balance. Looking at all your pictures there, triple beam balance, that one right there. Okay, that is a triple beam balance. Okay, that's used to measure things in grams. Okay, so example of something that I would measure, like a serving of cereal, maybe the mass of my pen, or maybe the mass of my scissors. Okay, that would be something I could measure in grams. All right, an electronic scale. So looking at the pictures again, electronic scale, that's this right here. Okay, this is used for measuring either just a few grams or measuring things in milligrams. Okay, so few grams or in milligrams. So if you need to measure something really, really small, and believe me, it's a real pain in the butt to measure milligrams. I've done it before in a lab. Really pain in the butt, difficult. All right, open up over here, conversion factors. Okay, conversion factors are something you need to be familiar with. You've actually should have worked with these a lot in chemistry. Okay, 1,000 grams. If I have 1,000 grams, what is that equivalent to? What does that equal? 1,000 grams is the same as 1 kilogram. Okay? If I have 1,000 milligrams, all right, that's equivalent to 1 gram. So those are your conversion factors there. And that can help you convert between kilograms and grams and milligrams. Okay? Now let's talk about some examples, just to give some context. Okay? A large paper clip. What do you think a large paper clip, what might have the mass, or what might be the mass of a large paper clip? A large paper clip would have a mass of about 1 gram. Okay, so 1 gram. A small textbook. So let me give you an example. Here we go. I got a textbook on Shakespeare. It's not super big. Okay. That is about 1 kilogram. Okay. And to help you out there, that's 2.2 pounds. That might be a little bit more helpful. Okay. And 2 grains of salt, that's 1 milligram. So picture dumping some salt in your hand, flicking all those pieces off and just leaving 2 little tiny pieces. That is 1 milligram. Okay. So that is what you need to know about mass. Now the quiz you guys are going to take in a couple days, you need to know everything in here but the conversion factors. The conversion factors, whenever we use them in class, I'll give them to you. But you need to know this, you need to know units of measure, instruments of measure, and examples. Okay? Alright, go and take that little paper, set it aside. Now we're going to talk about, let's talk about time. Alright, so find the 2 other strips left. Find the one that says seconds on it. Okay? We're going to fold this paper the same way we did the previous one. Take the ends in and fold them to the middle. Okay. Our units of measure include seconds, hours, and years. Seconds, hours, and years all measure time. Okay. So, seconds are our base units. Whenever we're doing measurements in physics, if we're going to do a calculation, 9 times out of 10 it's in seconds. Sometimes it's in hours, okay? But when we get to that, I'll clarify, okay? But if we're using a particular formula, we're usually using it in seconds. Okay, so other common use includes hours and years. You guys understand measuring these things, okay? Measuring time is something you are already aware of, okay? So something we would measure in seconds. A short race, okay? If you're racing a quarter mile or you're doing a foot race from one end of the school to the other, you would measure it in seconds. Okay? Hours, what's something you would measure in hours? Think about that. All right? I would measure, I don't know, the school day. I'd measure that in hours. How many hours are you in school? If someone asks you how much time you're in school, like, oh, I'm here for hours. Okay, you'd measure it out in hours. Years. Well, something you'd measure in years, your age. Okay, you measure your age in years. Okay, so these are the units of measure. These are things you'd measure in those units. This you are already familiar with. Okay, instruments of measure. A stopwatch. Hopefully you're all fairly familiar with stopwatches. Okay, the ones we're going to use in this class. Here's a picture of it. The little red ones. It has the on and reset and start stop. And this first number right here, let me zoom this in, see if I can make this work right. Okay. So over here, that's the hours. These two spaces right here represent minutes. These represent seconds. And these two tiny numbers at the end, that represents hundredths of a second. So this would be 1 minute, 27 seconds, 0.97 seconds. Okay, so that's how you would read that clock. Okay, that stopwatch. So stopwatches we use to measure time. Okay. So, for example, if we're measuring something with a stopwatch, we're usually measuring something that's 15 seconds or more. Okay? 15 seconds or more, that's just an approximate. If something's shorter than 15 seconds, we have that problem of the human error of how long it took you to like actually press the button and start and stop the stopwatch. And so you probably want to do something a little bit more accurate, which is what we call a photogate. So again, grabbing your pictures. Okay. The photogate, that's this. It actually says photogate on it. Okay. That thing, this is obviously a picture. In real life, it's about the size of a hand. Okay. And this little arch right here, on the inside, if you look very carefully at the picture, it's really hard to tell, there's a little dot right there, there's a little hole. And on the other side, on the inside there's another little hole. And there's a infrared beam that passes between those. And it's designed so that when something passes through that little arch, it hits start on the stopwatch. And then there'll be another photogate and it can hit stop. So it actually has a way of recording things that happen very, very, very quickly. Okay? So the photogate is used for things that are 15 seconds long or less. So things that happen very quickly. Okay? Now, conversion factors. These are easy. You know these. 60 seconds. What's equivalent to 60 seconds? 60 seconds is the same as 1 minute. Okay? 60 minutes is the same as equal to 1 hour. 24 hours is equal to 1 day. And 365 days, 1 year. Now, as I'm doing this, pay attention to your units. The abbreviation or the shorthand, seconds is just lowercase s, hours is just an H, not HR, just H, and years is YR. Okay? Now, this is one thing that kills most students on time, is paying attention to when you have to convert. So sometimes things are measured in minutes and seconds. So something took 1 minute and 45 seconds. Well, we don't use minutes in physics. We only use the seconds. So we need to convert that into just seconds. So there are 60 seconds in 1 minute, and then you add on 45 seconds more, you get 105 seconds. Okay, so we would use 105 seconds, not 1 minute 45 seconds in a physics class. Okay, try this one, 3 minutes 23 seconds. How much time is that? How much is that in seconds? Do the conversion yourself. 3 minutes and 23 seconds. Okay, so 60 plus 60 plus 60 for the 3 minutes plus the remaining 23. 60 times 3 is 180 plus 23. 203 seconds. Okay, so you need to be able to do those conversions. This you will see on the quiz. Okay, conversion factors for time, you will see this on the quiz. Fractions of an hour. This kills a lot of people too. Okay, you need to understand fractions of an hour because we don't do minutes. Okay, we don't use minutes in physics. It's got to be in seconds or it's got to be in hours. So this converts easily into seconds. These we need to convert into hours. 15 minutes, I'm not going to convert that into seconds. That's ridiculous. I'm going to convert it into hours. Okay? Now, there's kind of an easy way to do this, and I set it up here on my computer. Kind of give you a visual here. Okay, 15 minutes. If you know how to read a clock, the minute hand goes from the 12 to the 3. That's 15 minutes. Now look at it as a piece of the pie. That's 1/4 of the piece of a pie. So 1/4 of an hour, give it to me in decimal, 0.25 of an hour. Okay? 30 minutes. You all know that's half an hour. Look at that, from the 12 hand to the 6. So moving the minute hand from the 12 to 6, that's half of an hour. 30 minutes, half an hour, 0.50. Significant figures, you need that 0 in there. 0.50 of an hour. 45 minutes, the minute hand goes from the 12 all the way to the 9. That's 3/4 of the pie. 3/4 of an hour is 0.75 hours. All right, a little bit more tricky ones. We've got the 20 minutes. Okay, 20 minutes, one from the 12 to the 4. That's actually 1/3 of the pie. 1/3 of an hour, 0.333333 on repeating forever. Okay, 40 minutes from the 12 to the 8. That's 2/3 of an hour. 0.67. It's actually 0.6 repeating forever, but significant figures round it to 0.67. Okay? And 60 minutes, all the way, 1 full hour, 1.0 hours. Okay? So that's kind of how we do our time conversions. Okay, for fractions of an hour. So that 15 minutes, 0.25 hours. 30 minutes, 0.50. Don't forget the 0 for significant figures. 45 minutes, 0.75 of an hour. Okay. 20 minutes, 0.33 of an hour. 40 minutes, 0.67. And 60 minutes, 1.0. And that 0 is in there for, again, significant figures. Okay? So there we go. That is time. Go ahead and take it and set it to the side. Grab the last strip paper, fold it like we did before, bring the ends into the middle, and crease, ends to the middle and crease. Okay, in this one, our base unit is meters. Okay, so meters. Other common units include kilometers, centimeters, and millimeters. So here's a question for you. What are we measuring? If we're talking about meters, kilometers, centimeters, millimeters, what are we measuring? Well, here's a great thing. We're measuring a couple different possibilities. Usually we're talking about distance. When we're talking about something really long, like kilometers, we're talking about distance. All right? Or the distance from one place to the next. But we could also be talking about length. We also use length to measure these things. And height, or width, or depth. In the end, all of these ideas, distance, length, and height, these are all the same thing. It's just a matter of perspective and a matter of size and scale. But really, they are the same thing. Okay? So again, base units. This is on the quiz. Base units are meters. If we're going to be doing a calculation, we need to have your units in meters. Okay? Every once in a while, we deal with kilometers when we're talking about like the moving of a car. Okay, but meters, when we're talking about meters, something that you would measure in meters, I don't know, the dimensions of a building. All right, so how tall is the building? How long is the building? How long is the room? How high is the ceiling? All right, things like that, those sort of measurements, that's done in meters. Okay, kilometers, this is a distance across town. All right, if you want to know how far it is from here to HEB, well, the distance across town, we're going to measure that in kilometers. Okay? Centimeters are small. Okay? That's about a centimeter right there. So something you'd measure in centimeters, I don't know, a pencil. That's one. Now, one that you might not think about is actual height of a person. That's actually measured in centimeters. So here in the United States, if you ask, well, how tall are you? It's like, well, I'm 5'6". Well, that's feet and inches. In the metric system, you go to another country, like, how tall are you? And they're going to give it to you in centimeters. They're like, I'm 172 centimeters. Okay? So they'll give it to you in centimeters, the height of a person. Now, millimeters are even smaller than centimeters. Millimeters are really small. Thing you'd measure in millimeters, the size of an insect. All right? The size of insects, that's something I would measure in millimeters, especially in a science sort of setting. We don't use them, I mean, there's just so many things that are that small, so the most, in physics, the ones we're going to use a lot are meters and kilometers, but I need you to be aware of what centimeters and millimeters are. Okay? All right. Okay. So, those are our units of measure. The base units are meters, common units, kilometers, centimeters, and millimeters. Millimeters. All right, and notice the symbol, the abbreviation there. M, km, cm, mm. All lowercase. Okay. So instruments of measure. A metric ruler. Okay. So we all know what a ruler is. I don't actually have one here with me, which is silly, but you all know what a ruler is. Well, it's a metric ruler if it has centimeters on it. Okay. If we're measuring something in centimeters, we'll use a metric ruler. Meter stick. Okay. We can use this to measure centimeters or in meters. Something measuring in centimeters or in meters. So if I want to measure the length of my pencil, I could probably measure it with a ruler. But if I want to measure my height, I'm going to need to use like a meter stick. Okay? Metric measuring tape. So actually, let's back up for a moment. Go to our pictures. This right here, this is the end of a meter stick. If you notice that 90, 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, there are 100 centimeters. Each one of these is a centimeter, as it shows you right there. A centimeter, a centimeter. That little tiny measurement between two little lines, that's 1 millimeter. And this is all on the end of a meter stick, and a meter stick has 100 centimeters. Okay? So, that meter stick there, a metric measuring tape, that's this. Most of them aren't metric here in the United States. To find one metric is a little difficult, but it says M right there, so that tells me that's metric. And this I would use if I'm going to be measuring like a building or something like that, or something that's multiple meters long. It's easier than laying meter stick after meter stick after meter stick. Unfortunately, they're hard to find, so we don't actually have them in class. We use these. Okay? So, metric measuring tape is for measuring meters. Now, an odometer. What is an odometer? Okay, just looking at your pictures, there's just a few we haven't talked about yet. The odometer, that's this thing right here. That's the thing in your car that counts the miles. Well, if your car is built in another country or designed or to be sold in another country, it counts the kilometers. So an odometer is what you use to measure kilometers, the distance from one place to another. Okay? All right. So, units of measure, instruments of measure for measuring distance, length, and height. Now let's talk about conversion factors. Okay? If I have 1,000 meters, okay, so picture a meter stick. If you stand with a meter stick next to your side, it usually comes up to somewhere about above your waist. Okay? 1,000 of those, one meter stick after another, end to end to end to end to end, that is 1 kilometer. 100 centimeters, we were just discussing that. What is 100 centimeters? 1 meter stick. 1 meter stick is 1 meter long. Okay? 10 millimeters. Those little tiny little lines. If I put 10 of them together, what do I get? I get 1 centimeter. Okay? What if I, oh, typo. Cross that out, right? 1,000. One too many zeros there. 1,000 millimeters. If I have 1,000 millimeters, what do I have? I've got 1 meter. Okay, so these are conversion factors. Conversion factors for length will not be on the quiz. I want you to have them so when you need them, you can find them. All right, this journal entry we will refer to later on in class, much later on in the semester, whenever we need to do conversions. Okay? All right, so let's talk about some examples. The thickness of a credit card. Well, I don't have a credit card on me, but I have my badge, okay? So my badge, that right there, that thickness, that is about 1 millimeter. Actually really darn close to 1 millimeter, okay? The width of a girl's fingernail. All right, this applies well for girls, most girls, not all girls. Doesn't work well for guys. For guys, it's more like the pinky finger. The width of a girl's fingernail, that is about 1 centimeter. Now, something that's also helpful, the width of a large paper clip. So, girl's fingernail or a large paper clip. That'll help guys better because obviously your fingernails work. So a large paper clip is about 1 centimeter as well. Okay? The width of a door frame. Now the actual door, look at the front door right there in the classroom. That door itself isn't quite 1 meter. But if you look at the frame, the metal block around it, that from one side to the next is about 1 meter. Okay? Now, the distance from UHS to Academy. Okay? So here we go. We've got a map here. All right. So here's United High School. Here's the road going all the way around it. Right here is that intersection where the cops direct traffic in the morning. All right. From that intersection to the loop is 1 kilometer. Okay? It's actually not all the way to the loop. It's more to like that second entrance into Academy parking lot right there. That other entrance, so it's a little bit shy of that. So right from there to about right there is 1 kilometer. So the distance from UHS to Academy is 1 kilometer. Now, might be helpful to also know, if you go to the very north end of campus, the road where you go into campus right there in the morning, from there all the way to the loop, that's 1 mile. So if you add that extra piece in right there, the length of the school campus, plus that piece, the kilometer, that from here to there is 1 mile. Okay? All right, so here we go. That is that piece. So we now have our 3 pieces. I want you to take those 3 pieces and we are going to glue them in. Of course, I can find my glue. Here it is. Okay, so you don't need a lot of glue. Really don't need a lot. I'm going to take these and we're going to glue them in so that it doesn't really matter what order you glue them in. Again, please don't use too much glue. We don't want the pages sticking together, and I want the glue to last as long as I possibly can this semester. Okay. Alright. If you use too much glue, we run out faster. So please, just enough to make it stick, and that isn't a lot. Again, like I said, what order you glue them in doesn't particularly matter. Now, you should notice this is going to just about fill your page. Okay? Okay. All right. But notice we still have the pictures. Dun dun dun. Oops, they don't fit. So this is why I use what's called the oops page. Everybody look, 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 look. Eyes up here, eyes up here. Not turning the page, using the page right here in front of me. That blank page right there, that's where we're going to glue in these pictures. Okay? Glue them in with a little bit of space between them. We're going to label them so that you know what these different instruments are called. Okay? Okay, so here we go. Starting up here, we have measuring tape. Okay, we have a stopwatch. Okay, we're going to skip that one for right now. Right here we have a meter stick. Here's the odometer. If you need, you can write your little note there in the car. Alright, that little thing that's the counter in the car. Alright, here's an electronic scale. Alright. Down below here we have a triple beam balance. And it's a beam with an M, not an N. I'm not talking about frijoles. Okay, beam. It's called a triple beam balance because if you look at it, there's 1, 2, 3 little bars on there. Those bars are called beams. So it's a triple beam balance. There are actually quadruple beam balances, but they're not very common. Okay, and right here, just like it says in the name, Photogate. Okay, you do need to be familiar with these instruments. Now, the one that I haven't talked about yet. This is called a caliper. And let me show you physically. I have actually one right here. This is a caliper. Okay, you might see this in life, and I want you to know what it is, and I show you what it is. Okay, if you have something you need to measure very, very precise. Say I need to know the exact diameter of the lid to that marker. Okay, you squeeze it down, and then there's this fancy way of reading it. This one's electronic, and you turn it on and blah, blah, blah. But you notice, just kind of squeeze it in there, okay? It gives you a very exact measurement of something. The one thing I've actually used a caliper for, okay, is to measure the width of an eggshell for a lab I did in college. Okay, so that is a caliper. I want you to know what it is so that in life, if someone says grab the caliper, you don't feel like a dork. You know what they're talking about. Okay? Caliper. That will not show up on the quiz. I just want you to know what it is. Okay? So, quick review. Metric measurements. We do not use these in class. Alright? We use these in class. You need to get to know these. You need to be familiar with them and comfortable with them. You need to know your base units. Kilograms, meters, seconds. You need to know all the other common units. You need to know their approximate scales, what kind of things you would measure. You need to know the instruments that we use to measure these different units. You need to have an idea of examples. All right, how big and how small these things are. You need to know your fractions of an hour. You need to know your time conversions. You do not need to know mass conversions, and you do not need to know distance conversions, but you do need to know everything else for the quiz. Okay, and that is metric measurements, page 30 in your journal.